Algebra 2 Extra Credit Exam Corrections. Question number 1, Exam 1. X squared minus 5x plus 6 is less than 0. We factor it to be x minus 2 times x minus 3 is less than 0. Then we set x minus 2 times x minus 3 to 0. We find that x equals 2 and x equals 3. But then we have to test when x equals 2 and x equals 3. So we find the middle between 2 and 3 on our number line and choose something a little to the left of 2 and a little bit greater than 2. And find that when it's less than 2 it doesn't work, and when it's greater than 3 it doesn't work in our original equation, so it has to be between 2 and 3. So we find that the set of all x is such that x is greater than or equal to 2 or less than or equal to 3. Question 3b, we're finding the equation of a line where the x-intercept equals negative 8 and the y-intercept equals 6. As you can see, we can put it on our number line where we know that the x-intercept is negative 8 and the y-intercept is 6. And we're going to use the slope-intercept form, y equals mx plus b, to find this. So we need to find the slope. So if the x-intercept is negative 8 and the y-intercept is 6, how much do we go up and over to get it? Well, the answer actually is 6 over 8, up 6 over 8. So the slope is 3/4. We know the y-intercept is 6, so our equation is y equals 3/4 x plus 6. For 3c, we want to try and graph a line that goes through negative 1, 2 and is parallel to the line x equals 5. So as you can see, we draw the line x equals 5, and we graph negative 1, 2, which is x equals negative 1, and y is 2, which is fairly easy. So a line that is parallel to x equals 5 is x equals negative 1, so because it's just in the x-axis and it is parallel to x equals 5. For question 4, we need to write linear equations. The first type of linear equation is slope-intercept form, which is y equals mx plus b. So an example of that is y equals negative 2x plus 7, where negative 2 is the slope and y and 7 is the y-intercept. Another one is y minus y1 equals m times x minus x1, which is the x and y-intercept form. Y minus 7 equals 9 times x minus 8, where 9 is the slope, and 8, 7 is 1 point. The final type of linear equation is standard form, which is ax plus by equals c. Another example of that is 3x plus 2y equals 3. Now, for our next problem, we need to solve it graphically. We want to solve x plus 3y is less than 12. So we convert that to 3y is less than negative x plus 12. So then that goes to x plus y is less than 8, and y is less than or equal to negative x plus 8. So we need to graph these things. First, we graph the first one just as we would um, an equation that's with an equal sign, and we graph all of them. We shade if it's less than or equal, then we draw a straight line with no dashes and shade below it. If it's greater than, we shade above it, like you can see we did. And x is greater than or equal to 0. We just graph that and shade above it, and y is greater than or equal to 0. Now the only part that's our solution and our answer is the part that overlaps with which is shaded in black. Exponential and log equations quiz. We need to condense ln x minus 2 ln times x squared plus 1 plus 1/2 ln times 3 minus x to the 4th. So we convert that to log. So it becomes log x base e minus log x squared plus 1 squared minus e plus log 3 minus x to the 4th to the 1/2 base e. Then we change that to log x base e minus log, we multiply those things together because of log rules. We multiply the x squared plus 1 squared and the 3 minus x to the 4th to the 1/2 together because of the log plus a log rules. And then we take that answer, and because of another log rule, we subtract log x minus e minus log the solution of our previous x squared plus 1 squared times x minus x to the 4th to the 1/2 squared log base e, and then that's our answer. 2b, log rad 27 base 3, we need to convert to exponential form, which equals 3x equals rad 27. So we use our conversion of rads, and rad 27 is 3 to the 3 halves. So 3 to the 3 halves equals rad 27, so x equals 3 to the 3 halves. We need to solve the two decimal places for number 3. So it's 2 to the x minus 1 equals 10. We need to convert this to log form, which is log 10 base 2 equals x minus 1. Then we need to use our change of base formula, which is log 10 base 10 over log 2 base 10, which equals 3.2. So we plug that in. 3.2 equals x minus 1. Add 1 to both sides. X equals 3.32. Number 5, we want to expand log the cubed root of x plus 2 divided by x to the 4th times x squared plus 4. So that becomes 1 fifth times log x plus 2 minus 4 log x minus log x plus 4. Number 6, we want to expand log x plus 2 base 2 plus log x minus 1 base 2 equals 2. So with our log rules, we know that log a plus log b equals log a times b. So we multiply x plus 2 times x minus 1, just like in a previous problem, we find that that equals 2. Or no, we set that to equals 2. So then we do it x squared minus x plus 2x minus 2 equals 2. And then we just solve for x. Algebraically, x squared plus x minus 2 had 2 to both sides. Square root of x plus x equals the square root of 4. Square root of 4 is 2, so x equals 2. Algebra 2 review quizzes. Question number 3. We want to graph y equals negative 2x squared minus 6x plus 5. So first we want to find the axis of symmetry, which is negative b over 2a, which in this case is 6 divided by 4, which equals negative 3 halves. So the axis of symmetry is the point where the center of the parabola, or the top point of the parabola, you draw a line straight through it. And you can see I drew a red dotted line straight through it. Then we want to plug the axis of symmetry back into our equation to get what y is so we can get a point. Then we test other points around it, as you can see on the chart on the left, the x and y. And once we graph a couple points, we can kind of get an idea what the shape of our parabola is going to be. Then we just draw our parabola as we did here. Here we're trying to find equations of the quadratic function. We can see that the x-intercepts are negative 5 and 4, so the formula would be y equals x plus 5 times x minus 4, because you change the negatives and positives when you write the equation. Here we're solving this one by completing the square. So it's x squared minus 12x plus 44 equals y. So we set y to 0. So it becomes x squared minus 12x plus 44 equals 0. Then we add b over 2 to both sides. So it becomes x squared minus 12x plus 30, or b over 2 squared to both sides. Sorry, so it becomes x squared minus 12x plus 36 equals negative 8. So then we factor that side. It becomes x minus 6 times x minus 6 equals 8. So x minus 6 equals negative 8. It's negative 8. So then we just solve for x, so x equals negative 2. Here we're speaking in sigma notation. We want to find the sum of 5 integers where j is 3 and the rule is 1 over j. So it's 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7, and the answer is 1. For number 10, we'd like to do the same, for b, we want to do the same thing, sigma notation. First 5 integers, rule is j equals 3, the rule is 1 over b. So it's 1 over b plus 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 1 over b, which is 5 over b. Not bad. Now for number 10, we want to write the sum using sigma notation. So we know the sum is 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. So we're going to use sigma notation. There's 5 integers. It's j equals 1 cubed, which is the first integer, the first term. And we know the rule is j plus 1. For this one, we want to find the sum of the first 50 odd numbers. So we want to use a formula in this case, which is Tn equals the first, which is the nth term, which is the Tn term, which equals the term 1 plus n minus 1 times the difference. So that's the 50 terms plus 1 plus 49 times 2, which is the difference for each term. So T50 equals 99 when we solve it algebraically. 49 is the number of terms, 2 is the difference between each term, 1 is the first term. Solve it algebraically, we get T50 equals. Quiz, rational expressions from chapter 5, sum assignment. Okay, so number 2, we need to subtract and simplify 1 over x squared minus 1 minus 2 over x plus 1 squared. So we want to multiply both sides by the greatest common denominator, which in this case, on the right side, we multiply by x minus 1 over x minus 1. Right side, no, sorry, not greatest common denominator. We want to multiply it so we can have the same denominator for both. So on the left side, we multiply x plus 1 over x plus 1. Right side, we multiply by x minus 1 over x minus 1. So then we get x plus 1 over x plus 1 times x minus 1 times x plus 1 minus 2x minus 2 over x plus 1 times x plus 1 times x minus 1. So our answer is negative 1x plus 3 over x plus 1 times x plus 1 times x minus 1. Here we want to simplify x over y plus 1 divided by 1 minus y over x. So we want to change the numerator and the denominator to a fraction. So we can just do that by doing x plus y over y divided by x minus y over x, which equals x plus y over y times x over x minus y, because we know we can flip things when we divide, which then equals x times x plus y over y times x minus y. This is the first solution to solve this. In a second, I'll discuss the second solution. In solution number 2, we have the same problem, but in this case, we multiply by the least common denominator, which is xy. But we can only multiply this entire thing by 1, so we have to multiply x times x, so we have to multiply by xy over xy. So then this becomes x squared plus xy over xy minus y squared, so we simplify that, and then we factor, and we get x times x plus y over y times x minus y. This is the factored, most simplified version of the original. In this case, we're trying to solve 1 over x plus 1 plus 1 over x minus 2 equals x plus 3 over x squared minus x minus 2. So we want to multiply the whole thing, but at least we want to multiply both sides by the least common denominator of the equation, which is x plus 1 times x minus 2. So we do that. First, we expand things out, like you can see on the bottom. Then we multiply both sides, which then we get x minus 2 plus x plus 1 equals x plus 3. So then we simplify that, and we get 2x minus 1 equals x plus 3, and then we just solve for x, and we get x equals 4.